Good afternoon, everybody. So what we are about to complete together is a quadratics graphing flowchart, and this is going to summarize a lot of the big ideas we've done for this unit. And this is something that you get to bring in with you in addition to your multiplication chart for your test. So this is going to act as your cheat sheet. And everything we fill in, you're going to fill in as we move through your flowchart. You cannot add anything else to this. So Mr. Hack knows that already. You cannot add any additional notes or examples to this sheet, just what we fill in together right now. Starting on the left-hand side with expanding. So we're going to do some examples. Multiplying two binomials, and we're going to use FOIL. So just going to come up with some random numbers here. So an example would be, let's say, x plus 10 and x minus 3. So if we were to use FOIL, first times first, x times x is x squared. Outside, x times negative 3, negative 3x. 10 times x, 10x. 10 times negative 3, negative 30. Do not forget to collect like terms. Almost always it's the ones in the middle. Negative 3 plus 10 gives you 7 minus 30. Done. Sometimes what happens when students get kind of confused of what they're doing is they'll then try to factor this. If the question says expand or put into standard form, multiply and collect like terms, you're just leaving like that. Do not try to refactor this. And just as a quick review, if I was to ask you what the y-intercept is, hopefully everyone's saying negative 30. And if I asked you the direction of opening, hopefully you're saying up because the a value is positive, and so on. Now moving over to our special case. So if we want to square a binomial, meaning I have something that has brackets with squared, kind of looks like vertex form. So let's try something like this. 2x plus 6 squared plus 1. And we want to expand that, make it into standard form. First thing, never just multiply that 2, and you got to follow the rules of Bedmas, which says you got to do exponents first. When you square something, really what are you doing? You're multiplying by itself. So we're just going to write 2 of those. And then remember, you have 2 choices at this point. You could FOIL first or you could distribute first. It's really up to you. I encourage you to practice and pick a way. I'm not going to tell you which way to do it on a test. I like to FOIL first, so that's what I'm going to do. If you don't like that, you can do it your way. We'll get the exact same answer. When I FOIL first times first, x squared, outside, inside, 6x, 6x. Last, 6 times 6, 36, plus 1. Collect like terms. 6 plus 6 is 12. Now distribute that 2 in, which means multiply that 2 by everything inside. So that leaves me with 2x squared plus 24x plus 72 plus 1, which would give me a final answer of 2x squared, 24x plus 73 when you combine those 2 last terms. And that would be like the hardest expanding question I could ask you, something that's completely written in vertex form and you take it all the way to standard form. Again, quick review, what's my y-intercept? Shout it out. Hopefully you said 73. Direction of opening, hopefully you're all shouting up. And step pattern, 2, 6, 10, because my a value is 2. Those are all good review questions to ask yourself as you're going through this. So that's it for the expand. We're now going to move to the factoring side. And I'm just going to write this little note up here. Do not forget to check for a... You already have this written on yours, but do not forget to check for a greatest common factor first. So over here on the common factoring side, you see it's the largest number of variable that divides evenly into each term. So let's try this as an example. 15x cubed plus 6x squared minus 3x. Remember, factoring is the opposite of multiplying, so it's like dividing. So let's start off by drawing little fraction lines or divide lines. And then you got to ask yourself, what's the biggest number that goes into all of those? So hopefully you're thinking 3. That's the biggest number that goes into all of those. Do they all have an x in them? Yes. Do they all have x squared? No. Do they all have x cubed? No. So the largest power of x we can take out is just a 3x. Do not forget, your common factor that you divide by always goes out front. Then you do the division. 15 divided by 3 is 5. X cubed divided by x. 3 on top, 1 on the bottom. 3 minus 1 is 2. So that means you just have x squared. 6 divided by 3, 2. X squared divided by x is just x. And then negative 3 divided by 3 is just negative 1, and the x's cancel. And we have successfully common factored. And we're not going to go any further with that because this question is just saying common factor. And that right there, you don't have to write this on your test, but just to make note to yourself, that is your greatest common factor. Don't forget to write that. And remember, you can always check your answer. We're not going to check it for this cheat sheet, but you can always check your answer by multiplying that 3x into everything in the brackets. So that moves us on to factoring trinomials. Trinomials means there's 3 of them, an x squared, an x, and just a plain number. And when you see that, you're going to use the box or window method, or if you're really quick in your head, you can do that. So let's come up with a question here. X squared plus 9x plus 20. So 3 terms, a squared, an x, and a plain number. Check for a greatest common factor first. There is no greatest common factor other than 1. So we're going to go right to the box window method. Remember x squared there, 20 there, 9x there. Only 2 things that multiply to x squared, x and x. Now you have some options. Now remember, this is trial and error. Now for the sake of this video lesson, we're just going to come up with the right answers right away. But if that's not you, remember, it's not just going to pop into your head through the power of math magic. You have to actually try stuff. So look for numbers that multiply to 20, trial and error, scratch them out or erase them if they don't work. Try again. So if you're thinking of the right combination, 4 and 5, let's see if that works. 4 plus 5, definitely 9. 4 times 5, definitely 20, works out. Do not forget your factors are on the diagonals. So x plus 5, x plus 4. Again, we're not going to double check it, but you could on a test if you have extra time. FOIL, make sure you get the original question back. Moving a little bit further to the right of your flowchart, we're going to factor trinomials where we have an a value out front of x squared. And I'm going to do 2 examples for this, one where we can common factor and one that's a bit more difficult where we can't. So let's start with one that we can common factor first. So let's try this. 3x squared minus 6x minus 24. 3 terms. x squared x-plane number. So you gotta be thinking window, but again, always check for a common factor. In this case, the biggest number that goes into all of those is 3. They don't all have an x in them, so that's all we can take out. And when we divide, we have 3, then x squared, minus 2x, and then minus 8. And then what we have in brackets, that's a simple trinomial. So we can go to this, x squared minus 8 minus 2x. Only two things that multiply to x squared, x and x. Things that multiply to 8, 8 and 1, 4 and 2. Let's try 4 and 2, see what happens. Anyone know how to get negative 2 out of that? 4 plus 2 is 6. 4 minus 2 is 2. 2 minus 4, though, so if we make the 4 negative, which if that's negative, that's got to be negative. Negative 4 plus 2, negative 2, checks out. 2 times negative 4, negative 8, perfect. Don't forget, final answer, that common factor over here, that's got to go out front. And then your diagonals, x plus 2, x minus 4. And again, don't forget, it doesn't matter what order you write those factors in. Multiplication doesn't matter. Let's try, still underneath that heading, we're still going to factor something that has an a value other than 1, but this time we can't common factor. So let's try something. 4x squared plus 5x minus 6. So if I give you that on a test, you're taking a look, 3 terms, x squared x-plane number, that must mean box window method, and look for a common factor. Unfortunately, they don't all have x in them, and there's no number that goes into all of those except for 1. So we're going to go straight to this. And for those of you that you're really good at multiplying in your head, you use the quick way. Remember, you can't do it for these ones. You have to do the box method for these. 4x squared, top left, minus 6 right beside it, 5x. So these ones are a bit trickier because you now have multiple options. So yes, x and x, but it's 4, so it's got to multiply to 4. You could try 2 and 2 or 4 and 1. Again, it's totally trial and error. For the sake of this video, though, we'll go with the right combination. So 4 times 1 is 4. And then I want to get 6. So you could try 6 and 1, which again, trial and error. It's perfectly okay to be wrong in this. And then scratch it out, fix your mistake, try a different combination. Let's try, so 6 and 1 or 2 and 3 or 3 and 2 and 1 and 6. Let's try, let's try 2 and 3. 4 times 2, 8x, 1 times 3, 3x. Anyone see how to get 5 out of that? Make that negative. 8 minus 3 is 5. If that's negative, that has to be. And negative 3 times 2 is negative 6. It all checks out. For those of you on your achievement check, the last one I was there to actually mark or take a look at, don't forget, some of you left it just like this with the box completed. That's not your final answer. You have to actually make it look like factored form. So diagonals, x plus 2, and the other diagonal, 4x minus 3. And maybe over here to this one, the first one we did, we'll add in a little quick review. Zeros, what makes each bracket 0? Negative 2 and 4. Negative 2 plus 2 is 0. 4 minus 4 is 0. So this is your zeros. as a quick review that you can have for your test. And then the last piece of our flowchart, factoring a difference of squares. Remember, you are looking for two terms. They have to be minus, unless you've common factored something out first. And they have to be nice square roots. So let's try 9x squared minus 100. Two terms separated by minus. Do they have nice square roots? If you're not sure, use your square root button. Maybe make a little note there. You should get whole numbers, and then this always factors 1 plus and 1 minus. Doesn't matter what order you put those in. The square root of 9x squared. So square root of 9 is 3, and then x squared is x, so 3x, 3x. Square root of 100 is 10. It's as simple as that. Remember, if there was a common factor, you would check for that first, and you would common factor that out. Maybe let's do one like that then, just to be safe. We don't want anyone to forget. I would make this negative 2. Negative 2x squared plus 50. So yes, it satisfies two terms, but it's not minus, so it's not subtract, and neither of those two numbers have a nice square root. However, we always check for common factor first, which they don't have x's in them, but they are both divisible by 2. And don't forget, when that first number is negative, you should always common factor out a negative. So once we do that, we're left with x squared minus 25. That's a nice difference of squares now, which x plus 5 and x minus 5. Take the square root, x and x, one's plus, one's minus, take the square root of 25, you get 5. So hopefully that's a good review. You now have this to use for the rest of class to help you study, look over as a reference sheet, and then you get to bring this in, as I mentioned, for your test tomorrow. But don't write anything else on this. Have a good rest of your day, and good luck on your test tomorrow. I am going to do one more review with you tomorrow morning before your test, and then you'll be starting the next